A relation is a set of ordered pairs. You can either use these kind of brackets or these kind of brackets to write your ordered pairs in. An example would be these four ordered pairs. Notice there's brackets and brackets on either side. A relation can be shown as a table, a graph, or mapping. You've all seen tables and graphs. Now we're going to introduce mapping. New vocabulary word is domain. The domain are your x coordinates in a set of ordered pairs. Your range are your y coordinates in a set of ordered pairs. Let's look at the first example. Here's a relation, a group of ordered pairs. We're going to take these ordered pairs and we're first going to write them in this table. So the number 5 is going to go in the first x space. Next so it'll be 2, and so on. Now that I've written the numbers in the table, I'm going to actually find these on the graph. So my first ordered pair is going to be over 5 up 2, and I'm going to put a dot. My next dot is -7, so I'm going to go left 7, and +1 tells me to go up 1. My next dot is over 0, up 3, and put a dot. And my last dot is right 4, down 4, and we put a dot. As best you can. I know these graphs, the squares are really tiny. Now let's look at example 2. Example 2 is something new that we haven't seen before. It's called mapping, where we have these two ovals, and inside our ovals are numbers, and then there's arrows going from the x oval to the y oval. So I notice my first x value is -6, so I'm going to write that in the table. I notice that -6, the arrow goes to 0. So I'm going to put 0 in my y column. Then I notice I have a +1, and I have one arrow that goes to -5, and I have another arrow that goes to +4. So I'm going to have 2 1s in my x column. And then finally, I have an 8, and the 8 goes to -3. Now I'm going to take these and graph these on the graph. So the first dot is -6, so I'm going to go left 6, up 0. And again, do your best at graphing these. They're kind of hard. The next one, I'm going to go over 1 to the right, and I'm going to go down 5. And then the other one is going to be over 1 to the right and up 4. And my last one is going to be over 8 to the right and then down 3. So again, when you're done, you should have a group of dots on your graph. And lastly, we're going to look at the number 3 here. 3, they're giving me a graph. So the first thing I'm going to do is I'm going to look at my dots, and I'm going to find an ordered pair for each dot. So if I start with this dot right here that I just put a little green dot over top of, that's going to be -6 on the x, and it's going to be down 5. So -6, -5. Okay, I'm going to go to this dot right here. This dot is down, it's right or left 0, and it's straight down to -7. Look at the dot right next to it. So the dot over here is going to be right 4, down -7. And finally, this dot up here in quadrant number 1 is right 2, up 4. Don't forget, 0, 0 is in the middle. Also notice I just said the word quadrant. Remember, in the coordinate plane there are 4 quadrants. Quadrant 1, which we usually write in Roman numerals, is where 1 o'clock would be on a clock. Quadrant 4 is down here, where 4 o'clock would be on a clock. Okay, clocks go clockwise, but the coordinate plane goes counterclockwise. So quadrant 1, 2, 3, 4. Now I'm going to map these. So I'm going to draw an oval. I'm going to draw another oval. A lot of times we label it X. and y. Probably should have put them on top. So in my x column, I have -6, I have 0, I have 4, I have 2. In my y column, I have -5, I have -7, I have two -7, so I'm only going to write it once, and +4. Now, -6, I'm going to draw an arrow to the -5. 0 goes with -7. 4 also goes with -7, and 2 goes with 4. Okay, now we're going to go back and look at each example, and you'll notice underneath each example it says to find the domain and the range. So now I went back to example 1. Here it said to list the domain. So what I did was I took all of my x values, +5, -7, 0, and 4. That's what goes here. You can even look at the table and just copy the numbers that are in the x column. You can look in the table for the range, copy the numbers that are in the y column. I remember domain and range because I think alphabetical order. D comes before R in the dictionary. X comes before Y in the dictionary. So think alphabetical order. Same thing with example 2. The domain are the values that are in the X oval. -6, 1, 8. Range are the values that are in the Y circle. Now, up here in my first example, I did not write these in numerical order, but you will notice a lot of answers. They might even ask you in some of the programs that I have you do the practice in to put your domain and range in numerical order. So make sure you do this if it's asking you. On a test or a quiz, I don't care. You can just write the numbers in. Same thing with example 3. I took the numbers in the X column and I wrote them down. I took the numbers in the Y column and I wrote them for range over here. Now, in example 4, same thing I did before. I'm going to look at the dots that are on this graph. And I know for some of you these are kind of hard to see, but we're going to write those as ordered pairs. So my first dot is -5 up 3. That's the next dot up here is -1 up 8. Okay, we have this dot down here in quadrant 4, which is right 2, down 4. And then finally we have this dot here, which is right 4, up 0. Then I'm going to take those and I'm going to map them. So I'm going to do my one oval, my other oval, X, Y. I'm going to start by writing my X values. I have a -5. I have a -1, I have a 2, and I have a 4. Then I'm going to write my Y values. 3, 8, -4, and 0. And then I'm going to do my arrows. -5 goes to 3, -1 went with 8, 2 went with -4, and 4 went with 0. Again, my domain are my X values. So if you can make those little squiggly brackets, great. If you can't, just use these square brackets. So we're going to do -5, -1, 2, 4. My range, like I said, if you can't make the squiggle brackets, do these. 3, 8, -4, and 0. Next, we're going to look at the definition of a function. A function is a relation, which is a group of ordered pairs, in which each element in the domain is paired with exactly one element in the range. My hint is that the x term cannot repeat. So the x cannot repeat. So we're going to look at some of these examples. They want me to determine whether this is a function. So I'm going to use my highlighter tool. And we're really going to focus on the x values. Remember, the domain are the numbers that come first. They're the x's. I see a 6, a -4, a 2, and a -7. So all of those numbers are different. So I'm going to say that yes, this is a function. I'm going to look at number 6. Again, I'll use my highlighter for you. I have a +1, I have a -5, I have a -8, and a +1. Okay, so here's my problem right here. I have 2 +1s. And because I have one paired with 5 and one paired with -7, this is not a function. Now I'm going to look down here at number 7. Get my highlighter again. I have a 1, 2, 3, 4. So all of those are different. All the x numbers are different. So this is a function. Now you may be noticing, well, the y's are all 4. The y is allowed to repeat. The x is not. And finally, we're going to look at number 8. We have a -7, a -4, a -4. Now just when I said the 2 -4s, I'm going to stop right there. I noticed the one -4 is paired with 1. The other one is paired with -9. So this is not a function. Okay, let's look at number 9. Again, let's look at the x column. -2, -1, 0, 1, 2. Those are all different numbers. None of them are repeating. So yes, that's a function. Look at the next one. -7, -4, -1, 5, and 8. So again, I don't see any repeating numbers. So yes, this is a function. Number 11. Now here's where it gets a little tricky because we have the mapping again. We have -4. Notice though there's 2 arrows going out of -4. So if there's 2 arrows going out of your x value, this would not be a function, not a function. And lastly, to determine if a graph is a function, we can use the vertical line test. So a graph is a function if you draw a vertical line through the graph, and each line can only go through one dot. So that sounds a little crazy. Let me start drawing them for you. I'm going to start with number 12. If I draw a line, perfectly straight line, it only touches one dot. Perfectly straight line touches one dot. Now here I got to be careful, one dot. I can draw another line right there and it goes through one dot. And another line right there, one dot. So yes, number 12 is a function. I'm going to look at number 13. Straight line, one dot. Straight line, one dot. Straight line, one dot. Straight line, just went through 2 dots. So not a function. And then finally, number 14. You should be able to see right now. The lines are not the greatest. But every time I drew a line, it only went through one dot. So yes, this is a function.